Hello guys, today we will see how to create a realistic flag simulation in Houdini. I have already imported my flag geometry here. So we need to take a unpack node, and here you can see we have a path attribute. So we have to transfer that, and now take a split node, and we need to isolate our flag geometry. Now take a remesh node, and we have to increase the iterations to 100, and target size will be 0.005. Now let's make it an auto update again and see how the resolution is. It will take few seconds to calculate, so it is fine. Now we need to take a null here, and in which our flag will be attached to this plastic one. So to do that, first let's make a group here, and let's name it as attach. Set the group type to points, and we have to turn off this base group and turn on bounding regions, and here increase the bounding, and let's keep it around like this. Cool. Now let's take a vellum configure cloth, and we don't need to change anything here except the bend value. So here in the bend, choose this multiplier as 1e minus 9, and the rest angle scale will be 0.1. Here we have to take another constraint which will be attach vellum attached to geometry, and in this one we will feed our null. But the problem is we have to attach only this area, this plastic one, to its nearest point. So here, as you know, we have created one group called attach. So here we will choose attach. Now it will be attached to this, and here in the target group we will choose this plastic. Cool. Now take a vellum solver and connect it here. Let's play this and see how this look. As you can see, the cloths are getting stretched and it's look very weird. This is happening due to extremely low substeps and iterations. So let's make the substeps to 2 and constraint iteration to 200. Now if I play this, it won't get stretched too much, and here we can decrease the time scale to 0.5, since if you see this reference, the flag movement is extremely slow. So we have to do the same thing here as well. So I have slowed it down in the time scale. Now go in the forces tab and turn off this built-in wind, and we have to increase the damping ratio to 0.75. Now go in advanced tab, and we have to turn on this secondary constraint pass and multi pass. Doing this, we can achieve this kind of smaller, and you can see all these creases and wrinkles. So, and if I play this now, it won't be stretched that much. As you can see, but it will make the simulation little bit slow, not too much, but it will give very good result. So now if I go, although I can give you comparison as well. If I take a switch node and if I show you this, you can see this one was the old one, and this is with the secondary pass and multi pass on. You can see the difference and the details we are getting on the by turning on secondary pass on. Now we have to add wind in it. So to do this, we will go inside the Vellum solver and take pop wind node. So we need wind on the x axis. So here in the wind velocity we will give 2 here, and on the y axis we will give 1. The amplitude will be 1 and the swirl size will be 6.9, 0.69. Although you are free to play these wind values to get more better result. On the offset, since if you see this, where is my nuke? The wind is going on this direction. If I won't give any offset, then it will be kind of static wind which will be move on its own space, but it will not move forward. So to avoid that, I have animated the offset, make it feel that the wind is moving forward. So on the offset I write it $t. $t means time, and here as well I will keep $t multiplied by 0.1. Now if I play this, you can see it will feel like the wind is blowing forward. This wind will also not give accurate results, so I use the volume velocity as well. So here I will take a bound and I will increase this to 1.3, 1.3, and this will be 0.5, 0.5, 1, and I will take a ISO offset node and I will make it as a volume, and then I will scatter some point to it. This much point is enough. Now take a point velocity node and we have to add velocity to it, and let's keep the x value to 2.5 and y to 1 and z to -1, and let's visualize it. Here we have to turn on curl noise and increase the swirl size to 2, so it will be something like this. Now here also we have to animate the offset. So now if you see this, so you can see this is moving on its own axis, but if I add $t here, then as you can see it is looking like the wind is flowing on x axis. Here also we can do the same, $t into 0.1. Now it will be something like this. Again take a point velocity node I will use the duplicate of this and I will turn on add velocity, and here I will go in basics and choose keep incoming. Here also let's decrease the swirl size to 1.7, and it is enough. Let's take a volume rasterize attribute node and we have to rasterize our velocity. Here on the particle size, let's choose 0.1 and we will copy this node, go inside the vellum solver and I will choose pop advect by volumes. I will connect it here and here I will paste my and here let's keep the velocity scale to 0.4. In the advection method we will choose RK4. Now if I play this, you will see the major difference. Also one more thing, you can see on my this output, this rope is also moving and I have done this on post. So take a soft transform here and we have to choose these points. Now if I choose this and I have to choose radius, then here choose $GCX, $GCY, $GCZ. Here on the soft radius we have to decrease it around 0.03. Now if I move this, only this part will get moved. If I make it default, then the whole pole will get moved. So let's keep it around 0.03 only. And here in the translate we will write sign $F into 10 multiply by 0.003. Now if I choose this, then it will move like this. Now we have to again take a soft transform. I will make duplicate of it and here we have to choose middle part, this part only, and let's make the soft radius value to 0.35, and in the distance metric we have to choose the surface, not radius. Now it will only move this part. So what we have to do, we have to right click on the X parameter and choose motion effects, and then we have to choose noise. Here we can keep the amplitude to 0.04. Now if I go in back and I see, it will move like this. This is also a little bit fast, so to decrease it we can go here and choose the roughness to 1, and instead of sparse noise we will use alligator. Now go in channel and here reduce the sample rate to 0.8. So now you can see it is smoothly going. But now one issue is there, like if you see this, it have some mismatch. So to fix that, we can take a blend shape node, and the first one will go in null, the second one will go in soft transform, and we will blend it in 25 frames. So it will look like this. Cool. Now we can cache it out. Around 240 frames are fine for now. Take a Vellum post process node and connect it. Now take a file cache node. Here we have V, but on the Vellum solver, on the pop advect we have write well. So make sure to change this V, and now cache it again. So it is cache out, and as you can see, it have this kind of movement. Now if I merge this directly here, and let me color this red, you can see these problems are getting created. So to fix this, what we can do is take a rest node here, and here we can connect this, and we can choose extract rest, so it will move to its rest position, which we have already on the alembic geometry. Now we can take a time shift node and freeze it. Since it, you can see it has a timer here, so we will freeze it to make it static. Now we have to choose one node called attribute remap QL. You can install the package from the link in the description. It have cool node which will be very helpful. So here on the attribute remap, you can choose input attribute as a P, and here in the vector direction we have to choose X and press get on the min max. Now here we could make it this as a red and this as a black, and we will make it something like this. Yeah, cool. Now what we can do, we can take a, we need one more node called wrap. This node is very useful for doing CFX, then I prefer using this node. This node is also free. I will give this link in the description. So let me show you. This wrap node has been developed by Mommy, and it is free for personal use. And the package which I was saying is Qlib Houdini, and it is a free package. You can download it from GitHub or this site. I will give the link in the description. So now here we have to give the rest position, and then here we can give our null, and here we will give our soft transform. So now it will move like this. Now what we need to do is we have to copy this color attribute on our main geometry. We can take attribute copy node here and connect this to the file cache, and here we will copy our color attribute. Mix node, point mix QL. If you are not installing Qlib, then you can use lop function as well, but here you can use mix, and on the control attribute we will write color. and here we will choose blend envelope value to 1. So as you can see the difference, previously it was like this, but now it is smooth. Now if I merge both of them, and first let delete the color attribute color, and let's merge both of them here. Now you can see this won't create any artifacts problem, and it will be get blended smoothly. Now we have to deform the original cloth geometry. So since this geometry is of remeshed geometry, and this is our original geometry, so let's copy this null and take object merge, just paste it here, and take another wrap node, connect it here, and here we have to again choose a rest position node, and here we have to choose extract rest. So now it will move to its rest position, connect this to here and this to here, and here we can increase the iterations, smoothing iterations to something like this. It will make the cloth smoother, as you can see. Let's keep it around 8, and we are done.